extra material. What does this information tell you? It's the same thing, only it's described as, yes, the area of the rectangles under the curve as you take the number of rectangles to infinity. And yes, they are one and the same. Okay, very good. Let's go on then. Find the area of the region bound by, so here we go, bound by this curve and y equals 0. Don't think too hard on that. What's another name for this? It's the what? See, I heard both. Which one is it? Input axis or output axis? Which one is it? Input axis or output axis? Input, yeah. At this point, this axis is a number line, and at this point, the value is 0, and everywhere along here, it's not moving up and down, so everywhere along here, the output is 0. Okay, so we're bound by this curve. This is an upside-down parabola, right? Concave down parabola. And y equals 0. Find the area of the region bound by those two graphs. Now, what does this actually look like? Well, if the input is 0, what's the output? 0, okay. And so it's just saying it's going to come up and come back down. How do I know it's concave down? Negative leading coefficient, okay. How do I know what point this is over here? Because if I'm going to use this information, I need to know, is this going to go down over here? I need to know what this point is. How will you find this point? Find what? The 0 of, yeah. Yeah, if you look at that, and, you know, how about factoring out an x? I get negative 1 plus, negative x plus 3. And if I set that equal, we do this for derivatives, don't we? Same thing, set it equal to 0. So what's this point over here? 3. Okay, so we're going to use the definite integral from what to what? 0 to 3. Okay, so in this case, you know, we're not told what this other point is, but could you find it? Pretty easily, right? If you just think about all the math you've ever had, it's right there. Okay, now what goes in here? Yeah, the function we're trying to find. I mean, the area under the curve, so it would have to be negative x squared plus 3x, and what's missing? Dx. Now, this is the definite integral. That's equivalent to f of, capital F of what? Minus capital F of what? So f of 3 minus antiderivative 0. But in order to do all of that, we got to first find, what's our first step? Find the antiderivative. Okay, good. So let's find the antiderivative. So number 1, what is the antiderivative of that? In other words, what is the, how are we going to equate, what was this, negative x squared? Okay, so I don't want to write too much stuff there. We'll just say you need to find the antiderivative. That might be a good way of saying it. Find the antiderivative. So we've got the, what do we say, from 0 to 3, negative x squared plus, what was that, 3x dx is the same thing as, can you find the antiderivative of this? Negative x to the divided by 3 plus 3x squared divided by 2. Don't forget, you got to divide by that new exponent. Okay, then what do you do? Well, remember, we're in a definite integral. You can put plus c, but you don't have to. I won't count it off if you don't. What else do I do, though? How do I indicate? Okay, if I just do the vertical line, have I indicated what I want to? Because right now it looks like I'm only going to apply that. What's my? Yeah, to that. So I'm going to have to somehow, brackets or parentheses, enclose that. Otherwise, I'm not communicating what I need to with you. Okay, so now I need to find f of 3 minus f of 0. I truly believe that if you put in this step in here, you won't make the mistake that thousands and thousands and thousands of millions of people have made doing this work. And that is that they forget they have to go through the entire antiderivative with the 3 as an input before moving on to the input of 0. So you guys aren't going to make that mistake. So let's see. This is negative 3 cubed divided by 3 plus 3 times 3 squared divided by 2 minus, do I even have to do this part? 0, right? If I put 0 in that, it's just going to be 0. Equals. Now here's where I need to remind you, what is being cubed?
3.
Yeah, is it negative 3 or 3? And does it make a difference? It makes a difference if you're squaring it, doesn't it? Yeah, okay, but what am I cubing? 3 or negative 3?
3.
Yeah, just the 3, because the negative is not. If I wanted it to be a part of the base of that exponent, I would have to put it inside parentheses. Okay, so this is negative 27 divided by 3 plus 27 divided by 2 minus 0. Okay, so we just have to kind of do our common terms there. Actually, negative 27 divided by 3 is negative 9, and 27 halves, what is that? 13 and a half. Okay, so we're going to end up with 9 halves. 18 halves minus, negative 18 plus 27 be 9 halves on that. Okay, sorry about that. How do I check my work? Yeah, we're past that, okay? We've made some, how do I check this? Got a couple of ways, yeah. I can either do a graphical approach. Now remember, it may not come out to be exactly 9 halves or 4 1/2, but if you're close to that, you should have confidence that you did it okay. Or you can go back and use this. Okay. Okay, let's see here. I think what we'll do, I think what I like to do, this pretty much finishes it. This is all. This is it. Except for the section 5.2, we're going to go back and look at just more integration things, and we'll pick up. I am going to give you a few more, I'll give you in those videos a few more problems that kind of application type problems to look at. But as far as the amount of new information of how to work with calculus, aside from the applications, you guys, you made it through. Imagine. We're done. Oh, wait a minute. Let me turn.